Subscribers to this channel receive carefully researched ebooks, detailed videos showing real DIY woodworking projects being built step by step, and exclusive timber-related content that is not published publicly. The focus here is on understanding timber as a material, its behavior over time, its interaction with environment, and the subtle rules historic builders followed to make structures endure. Most modern timber failures are not caused by storms, insects, or decay alone. They come from design decisions that ignore how wood actually behaves in variable climates over decades. Buildings that seem solid at first often show sagging, twisting, or surface checking within a few years. In contrast, many structures from the 17th and 18th centuries, and even earlier, still stand in fair condition. Roof overhangs extended well beyond walls, shielding vertical posts and beams from direct rain exposure. This design principle explains why some timber-framed barns from the 1700s remain intact. Even though the external shingles have been replaced multiple times, modern builders often reduce overhangs to save material, exposing walls and posts to continuous moisture. That small design shortcut dramatically shortens structural lifespan. Historical builders chose timbers not solely based on species, but on growth patterns and density. Slow-grown, straight-grained wood was preferred because it swelled and shrank predictably. Wider, faster-grown boards, while nominally stronger in initial bending tests, often warped or twisted over time. Selecting the right timber for the right position, heavy, dense posts at high-stress points, lighter beams where movement was expected, was a core part of the design rule. This contrasts sharply with modern lumber selection, where code tables dictate size and species, often ignoring individual board characteristics. The result is a system optimized for manufacturing efficiency, not endurance. Even after installation, historical builders managed exposure carefully. Posts were sometimes partially buried in stone or brick bases to keep direct contact with wet soil to a minimum. Beams were coated in natural oils or left to weather, depending on expected stress and movement. Unlike modern chemical treatments, these methods did not seal wood completely, but moderated moisture absorption and promoted gradual acclimation. Modern treatments aim for immediate protection, which can trap moisture or prevent slow adaptation. The old world rule was to let the wood find equilibrium with its environment, then design the building to accommodate that equilibrium. Finally, the old world design rule always included a built-in tolerance. Beams were often oversized relative to immediate load, joints reinforced with multiple pegs, and spacing slightly generous. This wasn't wasteful. It was insurance against unknown variables, sudden storms, uneven foundation settlement, or unexpected moisture exposure. Modern codes rarely account for these long-term uncertainties, treating compliance as sufficient protection. Wood is not static. It responds slowly but relentlessly to load, moisture, and temperature. Ignoring these factors leads to predictable failures, even in compliant buildings. Historical builders accounted for these realities through design, not technology. By studying their rules, we can make better choices today, whether for restoration, reconstruction, or durable new construction. If you value understanding timber at this depth, consider subscribing to the Old World Timber email list. Beyond video, it offers extended research, historical case studies, and detailed analysis of timber in practice. Material knowledge that ensures your work, like the buildings we study, stands the test of time.